Okay, let's continue on with example 4. The techniques you can see here are rational and trig substitution. Okay, so just right off the bat, right, as you look at it, there's two different trig functions. Please don't do this, okay? Don't do this. I'm going to divide both sides by 2, and I'm going to set sine theta is equal to 3 over 2, or tangent theta is equal to 3 over 2. All right, it's very, very tempting to do that, right? It's like, divide both sides by 2 and set it equal to 3/2. Because that's what you taught me, Mrs. Zhu. No. These are constants, right? These are, more specifically, non-zero constants, right? The zero product rules basically says that if AB is equal to 0, then A is equal to 0, or B is equal to 0, right? It's called a zero product rule, right? These guys need to be zeros for you to set it equal to 0, but they're not, right? These are constants, non-zero constants, so you can't do that. Okay, so why don't we try doing this? Let's substitute tangent as sine theta over cosine theta, right? Your quotient identity. And then as soon as we do that, right, you can recognize that there is a rational function here. Whenever we're dealing with rational functions, we need to state our restriction, right? Cosine theta can't equal to 0, right, because you would be dividing by 0. Again, we kind of solved this before, right, in the context of graphing our secant functions. So in other words, theta cannot equal pi over 2, right? Theta, because if you take the cosine of pi over 2, you get 0. And theta cannot equal 3 pi over 2, right? Because cosine 3 pi over 2 is also equal to 0. If you were to condense this, right, it's pi over 2 plus pi n. Okay, so just make sure you state the restriction over here before we even start solving. Okay, so whenever we have a rational function, right, the way we go about approaching it to get rid of that rational function, right, in other words, a variable in the denominator, is we multiply by the LCD. So let's do that. The whole equation by the LCD. If I distribute the cosine, I'm going to get 2 sine squared here in the numerator. Cosine times this first term right here, right, is going to cancel out that cosine. So that disappears. And then if I distribute cosine over here, right, that is equal to 3 cosine of theta. Okay, so after I do that, right, notice I have 2 different trig functions. And this is kind of like example number 3, right, where you have to do a trig substitution, right? That was the strategy here. I said, hey, rational and trig substitution. So let's just simply substitute 1 minus cosine squared theta into our sine squared theta. Okay, so from here, right, the rest is just distributing, combining like terms. Let's do that. Distribute our 2. Right, and then whenever you have a squared term and then a non-squared term and then a constant, right, chances are we're going to do a little bit of factoring. Let's move all the terms over to the right side. 2 cosine squared theta plus 3 cosine of theta minus 2. Okay, so over here, right, just as before, we use the GCF. This time there should be a 0. And that looks like a theta here. Let me erase that really quickly and just call that a 0. Let's factor our trinomial. Okay, so 2 cosine of theta, parentheses, cosine of theta over here, right? And then we want to make that middle term 3. So I'm going to put a 2 over here, a 1 over here, and that's a plus 3. So let's call this plus 2, and call that minus 1. You can check it, right, by foiling the inner term. That's negative cosine theta. That's 4 cosine theta, right? Negative cosine plus 4 cosine. Does it give you 3 cosine here in the middle? Yes, it does. We factored it correctly. Let's use our zero product rule. I don't know why I keep writing theta over there. Again, this is 0 is equal to 2 cosine of theta minus 1. Or cosine of theta plus 2 is equal to 0. Okay? All right, so let's solve this one here on the right first. Cosine of theta is equal to negative 2. So, again, if we're doing this without a calculator, right, we want the exact values. Where is the x value? Negative 2 on the unit circle. Well, you think, right, the x value on the unit circle can only be between, right, this number right here can only be between -1 and 1, right? So it's not in that range. In fact, on this particular zero product that we use right here, this is not going to give you any solutions, okay? So this is, you could say undefined or no solution, okay? So on this particular cosine theta equals -2, there's no solution for that. All right, but over here, right, clearly you can see that if we isolate cosine theta, we're going to equal 1/2 over here. And for this, on the unit circle, right, the smaller value of the right triangle, right here, there's 1/2. And then also over here, there's 1/2. And those angles will be pi over 3, right? And then 5 pi over 3. Okay, so there's the first set of answers for the solutions in the interval from 0 to 2 pi. And then really there's no, if you look at it here, right, there's no common distance. From here to here, it's, you know, some distance, right? But it's not the same distance as I go from here to here. So if that's the case, there's no common distance, you can't really condense it. I'm just going to write pi over 3 plus 2 pi n, which is basically the period. And theta is equal to 5 pi over 3 plus 2 pi n. Okay, so if you can't find a common distance between the solutions, then you just simply add the period, right? Because the period basically tells you how far you have to go before you hit your original solution, right? It's the distance, the horizontal length of one cycle. Okay, so the very last example is probably going to be the trickiest one. So, you know, feel free to pause the video, study it a couple times, and then I'll give you guys a try in the notes, and, you know, you can try it on your own. I'll post the solution on Canvas. Okay, so this one I like to say, hey, whenever you see 2 trig, here's the strategy, I'll put it in parentheses, or the type of problem you see, 2 trig, and 2 trig functions and a constant. Okay, so the 2 trig functions, as long as they don't have a square in it, right? So over here, here's a trig that's not squared. Here's a trig that's not squared. And then here's my constant. Okay, so there's a particular strategy to solving 2 trigs and a non-zero constant. Okay, so what is that strategy? Because right now you can't substitute. I mean, you could write tangent as sine over cosine, and then maybe secant as 1 over cosine, right? And then, you know, maybe try to combine those cosines, but that's probably not the technique or strategy that you want to go over here. So in general, what I would encourage you to do is to try to isolate one trig function. Okay, so you can isolate the tangent or you can isolate the secant. I'm going to isolate the tangent. Okay, so in other words, get tangent by itself. Get one of the trig functions by itself. Okay, so if I get tangent by itself over here, I'm going to get secant of theta minus square root of 3. All right, so I've isolated the trig function, and then from here, right, this is the part where we have to do some squaring, okay? So in other words, a minus b quantity squared. If you forgot this, please don't, right? Because some of the fundamentals of algebra you just have to know right away. So let's start squaring. Okay, so if I square the left side, there's no issue here, right? That's tangent squared theta. If I square the right side, right, this is my a, this is my b again. Here's the formula for reference. You square the first term, you get secant squared theta minus 2 times ab. So if I do 2 times ab, that'd be 2 root 3 secant theta. And then plus the last term squared. Well, root 3 squared is just 3. Okay, so a little bit of foiling, right? And then from here, right, you could see, oh, you know, I have 2 different trig functions. I have a secant and then I have a tangent, right? So remember tangent squared, right? 1 plus tangent squared. Okay, it's always helpful to write it out here so you could see it is equal to secant squared theta. So if I get tangent squared theta by itself, right, it's secant squared theta minus 1, okay? So this guy right here goes to secant squared theta minus 1. And once you've gotten everything in terms of one trig function, right, the rest is just combining like terms, factoring, square roots if necessary. Okay, so right away I could see that these secant squares are going to cancel out, and I only have one secant that's left. I'm going to move my 2 root 3 secant theta to the left side, and then add 1 to the other side. I'm going to get 4. And then let's get secant theta by itself. Okay, so that's going to be 4 divided by 2 square root of 3. This is a 1, this is a 2. And it's kind of hard to solve in terms of secant, right? So from here, I would write 1 over cosine of theta. Right, secant is 1 over cosine is equal to 2 root 3. And then from here, right, you could do a little cross multiplication, get cosine of theta by itself. You get cosine of theta is equal to the square root of 2. All right, so on the unit circle, right, you could draw it out here. Where's cosine? The larger x value, clearly at pi over 6, right? This is the larger x value, right, the 0.86. And it's also positive in, what do you call it, quadrant 4, right? And that angle, of course, is the 11 pi over 6. Okay, so from here, it looks like you're done. But this is where the problem gets a little bit tricky, right? If you recall solving if you recall solving radical/rational equations, right? There's something funky that happens. But if you forgot it, here it is. Here's the concept. When you square both sides, there's extraneous solutions, okay? Potentially extraneous. Extraneous solutions may exist. Now, there's a mathematical reason why this is true. But I'm not going to go into it in this video. So basically it means you have to check. Okay, have to check your solutions. All right, so what do you mean check? Well, what I mean is you need to plug these values right here, pi over 6, 11 pi over 6, back into the original. Okay, so let me show you all the work on the checking. Theta is equal to pi over 6 into the original equation. Okay, so tangent of theta plus root 3 minus secant of theta, does it equal 0? All right, so tangent pi over 6 plus square root of 3, and then minus, so secant of pi over 6, same thing as 1 over cosine of pi over 6. So yes, this is going to get a little bit tedious, but you know, if you don't do it, you'll see that you're probably going to get you might get an extraneous solution, right? So again, tangent of pi over 6, right? I kind of drew it out here, right? Going back to this, root 3 over 2 comma 1/2. That's the ratio of y over x. So 1/2 over root 3 over 2, right? That's just 1 over root 3. Okay, and then the cosine of pi over 6, as you know, right, is root 3 over 2. Okay, so really you just have to kind of deal with these radicals over here. If I multiply top and bottom by root 3 over 3 on this first term, I'm going to get root 3 over 3. And then over here, right, if I'm going to add fractions, which I will, I'm going to multiply this guy by 3 root 3. So I have 3 root 3 over 3, right? And then this is just simply this guy flipped. That's 2 over root 3, okay? All right, so this left term over here, I'm going to get 4 root 3 over 3. And then if I multiply this guy by root 3 over 3, I'm going to get 2 root 3 over 3. And then, of course, 4 root 3 minus 2 root 3, that's 2 root 3, which clearly does not equal to 0. So what that tells you is that pi over 6 is extraneous. Okay, so we can cross that one off. All right, so let's check theta is equal to 11 pi over 6. Let's check it. See if this one works into the original. All right, so again, I know it's tedious, but sometimes math is very, very it can be very tedious. Okay, so minus 1 over cosine 11 pi over 6, question mark, does it equal 0? All right, so how's that going to change if we do 11 pi over 6? Well, 11 pi over 6 is over here, right? The x value is root 3 over 2. The y value is negative 1/2. So if I take the tangent of 11 pi over 6, negative 1/2 over root 3 over 2, right, will actually give me negative 1 over root 3, right? Negative 1 over root 3, okay? Cosine 11 pi over 6, that's still going to be positive root 3 over 2. Okay, so if you multiply top and bottom by root 3 over root 3, you're going to get negative root 3 over 3. If I multiply this guy by 3 over 3, I'm going to get 3 root 3 over 3. And then over here, this guy flipped is 2 root 3 again. And then if I simplify this on the left side, 3 root 3 minus root 3, I'm going to get 2 root 3 over 3. If I multiply this guy by root 3 over 3, the second term right here, 2 over root 3, multiplied by root 3 over 3, I'm going to get 2 root 3 over 3. And voila, 0 does equal to 0. So your final answer after all that work is that the only solution that you're going to have is 11 pi over 6. And then the general solution, theta is going to equal 11 pi over 6 plus 2 pi n. Okay. I believe on this one they do tell us to use Desmos. Okay, so let's just, let's verify that this solution is correct using our graphing calculator over here. If I can just get rid of the, let's see, I'm going to close this right here. Okay, so let's go to Desmos over here. This is from a previous problem. Okay, so just simply enter tangent of x plus the square root of 3. Okay, and then minus secant. Oops. Okay, so I need to enter a space bar over here, otherwise it's going to put it inside the radical. Okay, there we go. Minus secant of x. Okay, so what we're trying to look for, right, are the x-intercepts. That's where the graph touches the x-axis, right? So if you kind of look over here, if I click on the Desmos, right, you can see that 11 pi over 6 is in fact a solution. And then the next solution, right, would be 23 pi over 6, right? And that makes sense. That's the period from here. 23 pi over 6, 11 pi over 6, basically you add another 2 pi. Okay, so the only solution, as you can see from the graph, right, is in fact 11 pi over 6. So problem was a little bit tricky, right? You do need to remember to solve, whenever you start squaring something, you do need to solve for the extraneous, or check for the extraneous solutions. Anyways, just take your time with these problems. Okay, so example number 6. I'm not going to explain it to you in the video over here. I want you guys to try this on your own. Okay, so 1 minus cosine of theta minus square root of 3 times sine of theta is equal to 0. So, try this on your own, right? Isolate a single trig function. You can isolate the sine theta or you can isolate the cosine. Okay, so either solution would work. And I'm going to post the solution on Canvas. You could take a look at number 6, the detailed solution. I have it written there. And you can see me checking my solutions as well. And in my particular solution, I isolated the sine, but if you isolate cosine, you could do that as well and still get the same answer. But try it on your own first. If you get stuck, of course, you can ask me, and I will post, like I said, the solution on Canvas. You can see the work and everything else. Okay, so please take a look at example number 6, the solution, after you're done trying this, and then also take a look at number 7. There was an extra problem that, just for your reference, if you ever encounter a problem like number 7, sometimes these trig equations can get quite tricky.